Last example before we come up with a formula. 1/2, negative 1/4, positive 1/8, negative 1/16, plus dot, dot, dot. Sum this to infinity. Well, S sub 2, the sum of the first two terms, 1/2 minus 1/4, is going to give me 1/4, or 0.25. The sum of the first three terms, that is 1/2, subtract 1/4, add 1/8. That's going to give me 0.375. The sum of the first four terms, well, I'm going to take 1/2, I'm going to subtract 1/4, I'm going to add 1/8, I'm going to subtract 1/16. Plug all that in your calculator, you should be getting 0.3125. So it does look like these are getting close to 0.3. Let's try S sub 10 and use the formula for it. So S sub 10, the sum of the first 10 terms. Okay, I don't want to keep on going like this. It was easy up to 4, but not to 10. So the formula, S sub n is equal to term 1 bracket 1 minus r to the n all over bracket 1 minus r. So the sum of the first 10 terms is equal to 1/2 bracket 1 minus r. And what was our r value? We never did calculate that. Take any term and divide by the previous term, and I believe you're getting negative 1/2. Does that work? 1/2 of 1/2 times negative 1/2 gives me negative 1/4. Negative 1/4 times negative 1/2 gives me positive 1/8. Okay, so there's our r value. So when r is negative, we need to put it in brackets, our base in brackets to the power of 10, all over bracket 1 minus negative 1/2. I hope you can see that's 1.5. Okay, plug that in. I just did that and I got 0.33008. So it does seem that the partial sums ultimately increase. So this got bigger, and then this got smaller, and then that got bigger. So they're increasing, and then they're decreasing, but they keep on getting close to a third. So an estimate of our finite sum to infinity, gives us our sum to infinity, which would be 1/3. Okay, just note, write partial sums as a decimal because it's just easier to see if it's getting closer and closer to a number. That is it converging? And if you wrote all of these as fractions, I know it would be hard to see. Okay, determining partial sums can be a lot of work. Okay, so we can use the following formula to find the sum of an infinite geometric series as long as the common ratio r is in between -1 and +1. Another way of saying that is absolute value of r less than 1. These are the same thing. Basically, it has to be a proper fraction, but it can be negative, as we just saw there. Okay, so when we have an infinite sum, super simple, as long as you remember that. Okay, to use this, our common ratio has to always be a proper fraction. Okay, so let's see if this works and go back to those examples. So 1/2, 1/4, 1/8, 1/16. What is the sum to infinity using this formula? Well, it's term 1, 0.5, divided by 1 minus r. And we already calculated this. The r here was 1/2. So if I take 0.5 and I divide it by 0.5, it's telling me my sum to infinity is 1, which is exactly what we were estimating back here. 0.5124, so that was the second example, and the problem with this one is that the r value is 2, and r2 is bigger than 1, therefore the sum to infinity does not exist. This one's divergent. Don't go there. What about this one, where our terms alternate? So here's term 1. Our R value is negative 1/2. By alternating, I just meant the signs alternate. What is our sum to infinity? Well, it's equal to term 1, 0.5, divided by 1 minus R. 1 minus negative 1/2, or 1 plus 1/2. So I've got 1/2 divided by 1.5. And I hope that when you put that in your calculator, you get this. Your sum to infinity is 1/3. Okay, determine whether these infinite geometric series converge or diverge. If they converge, find the sum. If they diverge, don't, because there isn't one. Okay, so in order to know if it's going to converge or diverge, you start off by identifying your term 1 and your R value. Negative 9 over 27, which gives me negative 1/3. Okay, so if R is a proper fraction, then this is in between negative 1 and positive 1, so this will converge. What's the sum to infinity? The sum to infinity is equal to term 1 over bracket 1 minus R, 1 minus negative 1/3. And plug that in, and you get 20 1/4. So sum to infinity, 20.25. Term 1 here is 4. What's R? 8 divided by 4 gives, negative 8 divided by 4 gives me negative 2. The common ratio, negative 2, is not between negative 1 and 1, so this series diverges. So we don't have to do any work with it because there isn't one. It does not have a finite sum. Okay, you're going to turn to page 67 and try out example 3, and then do the check your understanding question 3. So, infinite geometric series, here is all your homework. Make sure you get that done. The quiz will be on these two on Monday.